Good day. My name is Mike. I live in Flagstaff, Arizona. I studied sheet metal at LeTourneau University for aircraft, which focused mainly on precision bending and controlling vibrations in your structures. I've worked with the heating companies here for 20 years, and I came across something phenomenal I'd like to share with you regarding laying out some of the most complicated connectors to lay out and build offset transitions and extremely irregular connectors, transition connectors. I call it the multi-triangle method, and it's pretty phenomenal. So to do our takeoff, there's a lot of similarities to a regular takeoff. The top distance is from the width of the top connection right there, whether it's front or backwards, this side or that side. The top distance goes from corner to corner. And the height, whether it's forward, backward, angled this way or angled that way, is from front corner to front corner. Whether it's angled this way, that way, or the other way. And the bottom is across the bottom on a straight line. Whether it's twisted this way, that way, up or down. The distance of the bottom is the width right across the bottom. And the diagonal of the corners from corner to corner, no matter which way it goes. We measure that diagonal distance and we write it on our sketch. The next edge in the rear is the distance from the corner to the corner in a straight line, no matter which way it goes, front, backwards, side, side, up, down. So on this side we'll have two triangles, and this rear shared edge shares the edge with the rear. That's a shared edge in the sheet metal. We're going to lay it out on paper first to make things easier to get a grasp of. Alright, here's our sketch with all the corner-to-corner dimensions laid out very carefully. You could go straight to the sheet metal, but we don't know what shape this is going to wind up taking. Swing the triangles using the trammel points or compass. Keeping shared edges together till we've got all the triangles swung. You can do either one side at a time, putting your flange and Pittsburgh on each face, but it works fine if you do the whole thing at once. Okay, here's my sketch again, and I've carefully swung all of my triangles here, keeping the mating edges together until I've got this form. I did run out of room, so I had to take more paper on each side, which is the advantage of drawing a scale draft before you lay it out on the sheet metal. The total form is going to look like this. This one, of course, is very straightforward, but some of them are extremely funky. I'm going to go ahead and lay this out on, actually I'm just going to use construction paper instead of sheet metal, because I'm not actually in my shop. And this is not actually one that we're going to put into use. But my blank is going to be that size and shape and form. So I'm going to re-swing all these onto the final sheet, and then we'll bend it up and see what it comes to. Okay, here's my finished cutout off of my draft. I'm going to put my quarter-inch flange, half-inch connectors for S and drive, Pittsburgh. You can see that this one is going to be a very usual straight one. Over here, I have an example of the two straight ducts are connected, slightly offset. The triangles put them together well. And here's an offset transition on the top. Over here we have our good old drop rail. That's a different thing. Alright, ready to bend. As we noted when we actually performed the measurements of taking it off, this connector is pretty straight, but we carefully maintained all the corner-to-corner straight line dimensions. Carefully maintaining all the corner-to-corner straight line dimensions. This here is the offset transition that was made, carefully maintaining all the straight line dimensions, which were measured right on site, taken directly off of the existing. No fantastic calculations even. And here's one where the ductwork was quite uneven. It connects it beautifully, just maintaining those corner-to-corner straight line distances with the triangle connectors. Phenomenal. I'm the last guy to learn this.